today we're moving on to perpendicular lines, and what you're going to be able to do, you will be able to identify perpendicular lines, and you will be able to write equations of perpendicular lines. So I want us to be able to identify via a graph what a perpendicular line looks like. So I want you to graph these two lines. Okay, so the first line, I have a y-intercept at -5, so I'm going to make a dot at -5. 1, 2, 3, 4, 5. And then my slope is -2/3. That means I'm going to go down 2, 1, 2, over 3. 1, 2, 3. Now I'm going to go the other direction, up to the other way 3. And I get a point right there. So I'm going to go ahead and just graph that line. Make sure you are not lazy with your graph when you put the little arrowheads. Now I'm going to graph the other one. I have a y-intercept at 1 and a slope of 3/2. That means up 3/2. Up 3, 1, 2, 3, over 2, 1 and 2. Now I'm going to go the other way. I'm going to be lazy and only do 3 points. Down 3 the other way 2. And I'm going to connect this. And I want you to notice that they are meeting in an interesting fashion. Do you see how they're meeting?
I do.
They're meeting in a 90-degree angle. We call this perpendicular. Any perpendicular line crosses with another line at a 90-degree angle. You can identify perpendicular lines, lines that will meet at that 90-degree angle, if you look at the relationship of their slope. The first slope was -2/3. The second slope was 3/2. Do you notice a relationship? Well, remember warm-up, I talked about reciprocal. I definitely flipped. I flipped it, and then what's the difference with their sign? Garrett?
Negative.
Yeah, I flipped it, and then they have an opposite sign.
That's magical.
So perpendicular lines will always have that relationship where they are going to be flipped slopes and opposite signs, meaning if one's positive, the other one will be negative. If one's negative, the other one will be positive. And they will always meet at that 90-degree angle. So perpendicular lines meet at a 90-degree angle. They intersect. I don't know what I meant there. They intersect. Must be that they intersect, right? They look like a T, like someone said. They always meet at that 90-degree angle. And then here is the other thing that you're going to be applying the most today. Their slopes are negative reciprocals of each other. Now, if you don't love negative, because if negative's going to mess you up, if I have, hey, what's negative the reciprocal of -3? 4s.
Whoa.
That might stress some kids out, like, I don't know what do you mean, it already is negative. This negative just means the opposite. Opposite sign, okay? It's the opposite sign. So the opposite sign would be 4/3 positive, because that's negative. But really, it's the same thing. A negative 4/3 is just positive 4/3. Okay? So, think of it as opposite sign or think of it as negative. That is your call. One of my learning targets that I have for you is being able to identify the negative reciprocal slope, because you have to apply that today doing anything with identifying the lines and creating an equation. You do not have this page. We're just going to go through that together. So remember, reciprocal means flipping, and negative means you change the sign. It's like that opposite sign. So this first one, 1/4. What is the perpendicular slope of this one? Flip it, change the sign. That's what I would personally do if I was a student. I would flip first, make it the opposite sign second. 5. You know what, I'm going to make 1 come out because I don't want to mess this up. So I'm going to flip it, 1 over 5, and make it the opposite sign. Okay, so now that you know how to identify perpendicular slopes, which are the ones that you flip or the reciprocal, and you make the opposite signs, your expectation to apply this knowledge is being able, given some graphs, know if the graphs are parallel, perpendicular, or neither. Parallel, same slope. So if you're given something, of course the first thing you want to do is make sure y is by itself, but here I have y alone because I just want a basic introduction. Go ahead and box all of your slopes up. And then you want to compare your slopes. So remember, parallel are the same slopes, perpendicular are negative reciprocal. That means you flipped it and it's the opposite sign. So I don't know, I just kind of look at that first one. I go top to bottom. So I'm looking at the slope of 4. I want to find the same thing as 4 or the flipped negative, which would be negative 1 over 4. So I'm looking at all the other lines and I'm seeing, okay, are there any with a slope of 4? That would be parallel. And are there any with negative 1/4? That would be perpendicular. So I'm looking, oh, here's a perpendicular one, so I can write that pairing. Okay, looking down some more. I see a 4 here. So then I know that that's parallel. So I'm going to say y equals 4x minus 3. And y equals 4x minus 4. They're parallel, same slope. So I've analyzed those. Next, 2. Well, my parallel slope would be 2. My perpendicular slope would be negative 1/2, right? You flip it, make it the opposite sign. So I'm going to go and see if I can find a 2 or a negative 1/2. Here's a negative 1/2. So that's the perpendicular slope. So I have y equals 2x plus 1 and y equals negative 1/2 x. They are perpendicular. And that's all I have with that one. The next set, I have 2/3. So my parallel slope would be 2/3. My perpendicular slope would be negative 3 over 2. So I'm looking for 2/3 or negative 3 over 2. I found it. So it was y equals 2/3 x minus 4 and y equals negative 3 over 2x plus 3. And then I'm done. My last two are the same. So I just know they're parallel, right? Same, parallel. So y equals negative 7x minus 2, and y equals negative 7, that's a 7, x minus 4. Parallel, same. Perpendicular, negative the reciprocal. Parallel we did Friday. Perpendicular, new stuff, level 4 abstractness, meaning it is difficult to apply. Okay? Now let's apply it again.
Again?
Yeah, let's apply it again. So you're going to be given an equation of a line, and I'm going to ask you to tell me what the perpendicular slope is. The first thing you do is need to get y alone. Slope-intercept, also known as y alone. That's the first thing you need to do always. I just happened to notice as I started this problem that y already is by itself. So all I do is box off the slope. So my slope is 3 over 1. So my perpendicular slope is going to be negative 1/3. Okay, this next one, I cannot analyze the slope yet because y is not by itself. So I'm going to divide everything by 2. Then you get y equals 2x minus 3/2. I do not care about that y-intercept. I only care about the slope. So my slope is 2 over 1, and my perpendicular would be flip it and make it the opposite sign. Okay? The next one, get y alone plus 3x. And then I have 4y equals 3x plus 12. Divide through by that coefficient. This is a y, oopsies, that's a y. So then I get y equals 3 over 4x plus 3. I'm just not showing my division there, but that's absolutely what I did. So my slope is 3 over 4. So my perpendicular slope is going to be to flip it and make it negative. Negative 4 over 3. I'm just going to go ahead and do this bottom one here, since the other ones seem a little redundant. Again, my goal was to isolate. Y is isolated first. That's more like basic level 3. Then we go to definite level 4 processing, where you have to get y alone first. And then that's what this is. And then giving you a fraction first. That's going to turn to a whole number. So my slope, I can analyze it right away because y is by itself, negative 1/3. So my perpendicular slope would be flip it, make it the opposite sign. So positive 3 over 1 or just 3. Okay? Make that 1 hide. If that 1 can hide, you make it hide.